3D. So some occasions you need to do a bit of 3D visualization. Now some people, as I said, they struggle. They'll look at this diagram and they can't picture where the angles are that they're interested in or where things join up. And that's not that you're good at maths or not good at maths, it's just a personal good at visualization thing. So apologies if you're rubbish at it. Something that may help is if they haven't done, it's a good idea to label the vertices, okay? Because that enables you to, when you're redrawing your triangles, to actually have labels on them so you can see clearly where they're coming from. So if that's my solid, if I was looking at this line going through the middle, so you can see that it goes from B, which is this top back bit, to H, which is this front bottom bit. So that obviously goes through the block. If I was trying to form a right angle triangle there, the best thing to do is to drop it down, okay, so directly beneath the top of it, and then I could join it up here. Now, some people are not good at realizing that this bit here would be your right angle, because obviously as it's drawn, it's not like that. So it's better to redraw it as a proper right angle triangle. But this is where, as I say, the labels come into play, because if you knew that was B, that was F, that was H, then it's a lot easier when it comes to labeling. Okay? So here's a prism. The end faces are squares, the sides of length 8, the length of the prism is 15. Find the angle between the lengths EG and CE. So here we need an angle. So EG is this diagonal here, and CE goes through my shape there. Okay, we'll probably should do some labeling of the information they've given us. So they told us that the end faces are squares of side length 8. So that means that these bad boys are all 8. Obviously, and all of them are, but I can't construct more. And then this would be 15, so this, and so with these bits here. Okay. So yeah, so these end bits, the CDHG, that would be a square. Yeah.
This looks more like a square on there than it does on the paper.
Roger that. Well, and on the diagrams they give you, they won't be drawn to scale, so you just have to believe what they say. Okay. Right. So we're happy that that's what we're trying to find. So let's label what we're actually trying. So if we're trying to find, so we've got CEG forms our triangle. So CEG. Do we all see that this bit here, the CGE, this bit here would be our right angle?
Yeah.
Okay. We know, do we know any information? So CG, we know is 8. We don't know EG though, because that goes down diagonally, so we don't know that. And they're trying to find this angle here. So in order for us to be able to calculate that, we obviously need some additional information. Now, luckily, if I'm missing this length here, I can see that that's also a right angle triangle. Yes? So I'm now going to label my triangle EGH or EHG. And that will enable me to find my hypotenuse, or the length EG, which is what I was missing here. So EH is 15 and GH is 8. So obviously Pythag is going to be 8 squared plus 15 squared, because it's the hypotenuse, yeah? And I would suggest probably leave it as the square root of something. Rather than round stuff. Remember, when we're round, you lose some accuracy, so you can just leave it as the third form.
Why is these? Oh, never mind. Just joking.
Okay, quick step. So me telling you to leave it as the square root is dark because it's a whole number. So So we've got our new triangle. So that means that I can now transfer this information here to our triangle up above, because that's what we needed in order to calculate that. And here it's a right angle situation, so we can use SOHCAHTOA. So we've got to decide which one of these to use. So we label the H, the O, the A. The H is nothing to do with us, so it's an O and an A situation. So we're looking at TOA. So we would say tan of the angle is 8/17. And there's our missing angle. Okay? Alright, so we need to find length EG. So EG, so we're trying to find that length. We will see that there's a right angle triangle there.
Yeah.
So if we were trying to find EG, that's going to be my hypotenuse. This bit would be my other letter H. And so HG, you can see from the diagram, is 10, and EH would be the same as this, so that's 3. So that's going to be 10 squared plus 3 squared. So that's root 109. So they want the answer to 3/6, so they would actually round that. So I would suggest if you need to use EG for another calculation, use the root 109 format. So do we know what that is to 3/6?
10.4.
10.4. So how much then? Centimeters. And so CE, I should do a B down here. So CE is going through the diagram. Oh, that's a really bad diagram. So that's E at the bottom, C at the top, and so the other letter we're looking at is G. Handily, we just found EG, so that's going to be root 109. And CG, we know, is 5. And so my length CE is going to be the square root of root 109 squared plus 5 squared.
Wait, that's not a right angle, is it?
Yes.
C
to G to E. The right angle's at G. Are you with me? So that's going to be 109 plus 25. So CE is the square root of 134. That mental maths. Amazing. See, mini calculators out.
Otherwise. I have 11.6.
11.6, merci. And now the angle CE makes with the plane EFGH. Now often they use phrases like this. Do we all understand what they mean by plane?
Yeah.
So plane is like a face. So they labeled it with 4 letters. So EFGH. So EFGH, if we look to see where it is, it's that base part. Okay? So they will say it's a plane. And we want to know what the line CE. So here's my CE. And what angle does it make with this plane on the bottom? Well, it's going to be this angle here. Yeah? Now, they did highlight that. They said angle CEG. So they told you which angle they're talking about, but they're not always going to do that. So sometimes you're going to need to use your noggin there. Okay? So actually, it's my same diagram as here. So this is part C. I'm looking for this angle here. Now the fact that we've just found this to be root 134 means that I actually could use SOCAR or TOA to find that missing angle. You get to pick.
So,
Okay, let's use so. So the sine of the angle is the opposite over the height. So it's 5 over root 109. But obviously, because we have all three, you could have used any of them. I would have warned you against using car, just because we calculated both of these two values. But it's not the end of the world, but you're going to have to use something to calculate them. So I don't. So, well done for spotting the deliberate error. And that it should have been a root what said more on the bottom. Now, Natasha, do we have an answer for that one? 25.6? Is that the same answer?
No.
Oh. Okay. So we're good there? Yeah, nice, easy, cinchy. Right, we've now got a pyramid, so no longer is a prism, because a pyramid is not a prism. Okay, it's a square-based pyramid, and I don't know why that they've got this V here. Like, it's a bit stupid. So can we just ignore this V? So they've told us that from V to the center of this bad boy here is 12. Okay? And so we need to visualize what's going on. So they want to know Vx. Okay, so can we all see that Vx is down one of these vertices? Yeah? And so that's the hypotenuse for that triangle. Do we all see that?
Yeah.
So for A, we're looking at the triangle V. I'm going to, what should I put? O for center? Yeah. OX. Yeah. You know in circle theorems, it's always O.
Yeah.
Yeah, you started doubting.
No, it's
I saw that doubt.
See?
Yeah.
No. Not that good too.
Anyway, I've chosen O.
Sorry.
But I don't have length OX. Okay, so I'm struggling here. But what can I do? Can anyone see anything? Let's look at the information they've given us. So they've told us this is 8 and this is 6. Is that going to help us?
Yes, you know you're not. The person doesn't do your head just like no.
Tell me, Leah, what you're saying?
The VY thing. Well, they're not the V, the O. So the Y.
Okay.
No.
Although secretly we're talking about this one here.
I don't know. You have to use the 6 and 8.
We do have to use the 6 and 8. But we all need to establish why. I don't want to just tell you. So I'm telling you we need to find OX. So do you think there's a way of thinking, oh, if we extended that.
Oh, yeah. And then you use the 6 and 8 to like that.
Yes. So if that was Z and that was X, okay, O's here smack bang in the middle, isn't it?
Oh, so it's just half of.
Got you.
Yes.
Yeah.
So me telling you that I was going to make you work it out, I totally didn't like help. But we will see that, yes? So because we know O is in the center, we need to know just OX. If we found ZX, which is the whole diagonal, then obviously from O to X will be half of that. So go back to our labels, so we know that WX is 8 and ZW is obviously the same as this, so that's 6. So that's going to be 6 squared plus 8 squared. So 36 and 64, that's 100, isn't it? So that whole length is 10.
Why am I struggling to do this?
I don't know. So if Z to X is 10, that means that O to X is going to be Just 5. Très bien. So now I can find b to x. So that's going to be 12 squared, 5 squared. 144 plus 25 is root 169, which is 13. Amazing. Pythagorean triples. Huh? So, that's A, check. B is the angle between Bx and the base. So again, they're getting you to visualize. So they've told you again Bxz. So they've stretched it all the way to Z. But secretly, obviously, Bxo is going to be the same angle. So part B is looking for this angle theta. And again, you've got all 3 sides, so you can use any of the SOCAR or TOA. And you've calculated 2 of them, so it really makes a difference.
That says 109.
169.
Oh.
It's very clear. Are we using SOCAR TOA? So sine of theta is 12 over 13. So theta is sine minus 1, 12, 13. Theta is Alright, so we've got 67.4. I on purpose chose the correct one this time. And then part C, we're looking for the area of the pyramid face. Okay, so we're looking at the pyramid face, VWX. So VWX. So it's that triangle there. So V. Oh my God. All right. So on that triangle, we only know at the moment this bad boy here. No, shut up, Miss Harrison. We don't. We know the x as well, don't we? That was 10, wasn't it? 13. Oh my gosh. Now, if the x is 13, do we know anything else?
VW.
VW has to be the same, doesn't it? Yes?
Oh,
Well, because otherwise it will be a really dodgy pyramid. Did you say something different?
No. She said it's an equilateral. She said it's an equilateral triangle.
Oh, almost equilateral.
Isosceles.
An isosceles.
Yes.
Alright, so we've got an isosceles triangle here. We need to find the area bit. We don't know any angles though. So we could, now we know how to do it, use the cosine rule to find an angle if we wished. Okay? Or secretly we could just recognize that if we drew a line down the middle, we would have 2 right angle triangles. Okay? So this would obviously be 4. If we found this measurement here, this perpendicular height, we could do base times height divided by 2. Yes? And then multiply that answer by 2 because there's 2 of them. Or actually, we could use the whole base times height divided by 2. Yeah, so we wouldn't actually. But to find this measurement here, so V to the bottom, so let's call it H, the whole thing. We would do, so H squared is 13 squared minus 4 squared. 169 take away 16 is 153. 169 take away 16. That's right, isn't it? Yeah. So 8 is that. We'll leave it. And so that the area then is going to be the base, which is 8, multiplied by that height, divided by 2. Okay, so that's our normal base times height divided by 2. But as I said, you could have gone into doing sine cosine rule, and then you can use the area rule, and had you found a missing angle. No, actually, you wouldn't use the sine rule at all because you've got triangles. So you would use the cosine rule. And that's the thing is, once you've learned about cosine rule, people assume you have to use it for stuff like this, but you don't. Okay, you can go back to basics if it's a little bit easier. So does anyone know what 8 multiplied by root 153 divided by 2 is?
No. No. 49.5.
Okay, that took a while, so we're not quite sure.
No,
that's
it.
Oh, everyone got their caps out there. Shush now. Right, okay, oh, no, we're not done. Yes, got more.
No.
Oh, yes. How far are we on? 20 minutes, okay. So the pyramid, ABCD has a square base, size 15. Its other faces are congruent isosceles triangles. What's that mean? Congruent. Yeah, exactly the same. But we knew that anyway from that last one. And realistically, you're not going to have a pyramid that closes up unless they're all the same triangles. If it's a square base. So the sides are all 24. So there's slopes of 24. Find these angles. A, B, D. Okay. A, B, D. A, B, D. So this bad boy here. So we know that AD is 15. Do you know anything else?
Yeah,
This side's 15, yeah? AB? Yes, good.
and then you can just do
And we're trying to find that theta. So we're doing HOA. So with H is useless to us, so we're looking at TOA. So tan theta is 15 over 15. So tan, oh no, let's do theta. Theta is tan to the minus 1 of 1. Now, do we remember what that is?
45.
You put it in your calc, cheater. Let's remember that from our special triangles that we learned all about. Remember? Okay, that's good because it was like only 3 lessons or something. So do you remember that? Oh, did you? That was a bit you did do, wasn't it?
I did.
Is that when you tag teamed with Sally?
Wait,
Yeah.
one's a
I don't know.
one's an equilateral.
Remember there were 2 triangles, an equilateral of 2, 2, 2, cut it in half, 1, so that this is 60, this is 30, and then you've got, oh gosh, that's so not a triangle. And then you've got a 1, 1, 2, root 2,
Yeah.
No, we
and
didn't
these
do
are
that.
45. Yeah, we tend to do that.
I didn't do that.
Okay, well I sent you the notes and the videos on there, so that's alright, so theta is 45. So B, E, D, C. E, D, C. Okay. What? Now, this bad boy is not a right angle. Can we see that?
Yeah.
Yes?
Yes, we can.
So ED, do we know like EG?
Yes.
What is it?
7.
Nice. And we know obviously EC is also 24. And DC, do we know the length of that bad boy? 15. Oh, look at that's cheap. So EDC. What do we propose to do here? Should we use the cosine rule just because? Yeah. So because we've got 3 side lengths and an angle that we need to find, we would say that cos theta. So which is the side length that we have to subtract?
24.
Nice. That one. Obviously it's 224. So we've got 24 squared plus 15. Oh, that's not 15. 15 squared. Subtract 24 squared over 24 multiplied by 15. So obviously secretly these two 24 squareds cancel each other out. So theta is cos to the minus 1 of 15 squared over 25. 2 BC. 2. How many people? I just shouted 2 BC, but you'll see that all that. Yes. Righty-ho, so that's 71.8.
Oh.
EAC. Oh, let's have a look at the diagram. EAC. Oh, gosh, right. Oops. EAC. Now, well, we've got a choice. I mean, we could bring it down to the centre and do that. That's a right-angled one, but we don't have to.
Couldn't we have done that?
Yeah, we could have done that for this bad boy. Yeah, totally. But we were practicing our cosine. Right. Do we know AC?
24. Okay, just looking.
Do we? No, we don't know that. Do we know EA?
24.
And EC is 24, isn't it?
Yes.
And what are we trying to find? EAC, this bad boy.
Yeah.
So, if we're trying to find this angle, we want to use the cosine angle, we need to find AC. Oh, I've got some ways we could do this. So we can find AC because it goes through the centre, yes? Doesn't it?
Yeah.
Yeah, so that's the hypotenuse. So we could do AC is the square root of 15 squared plus 15 squared.
Maybe. What?
AC.
Yeah.
So looking at the diagram, it's AC goes through the middle, yes?
Yeah.
As a square, so it's 15 squared plus 15 squared, the square root in. Yeah? What is it? Give me a few digits. 21 point, what? 2132. Okay, so that's our AC. So we can stick that bad boy in here, 21.2122. And then we can use the cosine rule to find that. And so we've got cos theta, it's 21.232 squared plus 24 squared minus 24 squared over 2. Okay, so there's the answer. Right, okay, so a cuboid has dying. Sorry. So a cuboid has sides like 8. So I just call what I do. I did it
No.
8, 12, 15. Diagonals of 3 faces are drawn as shown. Okay, so they're going through all the faces. And nothing's going through the diagram. Yeah, you're happy with that? So whilst this bad boy looks like it's going through, it's not. It's just going through the face. So the diagonals of the 3 faces are drawn. Find the lengths of A, B, B, C, and C, A. And let's go first. Alright, so A, B. So obviously that's going to be this right angle triangle. So A. So A, B. So our third letter was here, that'd be this one here. Let's just call that T. Trevor. Yeah. So that's 15 and that's 8. So 15 squared plus 8 squared and square root it. BC. That's 17, we have to see. And 12, 15, oh, yeah. Oh, and now we're doing BC. So I've got BDC. So I've got that triangle up there. So that's 12 squared plus 15 squared and square rooted. So the other one is AC. Oh, C. And we'll call this S for Sandra. So F is 8 and AS is 12. Huh?
I'm really just thinking that.
Huh? 19.2
Yes, I have.
and 12 squared plus 8 squared 14.4. So 17, then 19.2, then 14.4.
I can't even see that.
Oh my god.
Miss Ina or something.
Yes, they often ask me about French.
Really?
Talk to. Anyway. Right, so here's my triangle. So I've input all my information we just found in part A. So we're now got 3 sides, we're trying to find an angle, so we need to use the cosine rule. And remember, we need to establish which one we're subtracting. So which one are we subtracting?
17.
Yeah, so we're going to do cos theta is 19.2 squared. Did Leah say something else?
Yes, she did. I do my triangle different than you though. How did you get 14? I don't think about it.
Okay, so theta is cos minus 1 of that. Maybe we should have our guest lecturers back.
Do you want?
Alright, so we've got 58.7. Let's go back to formula. Alright, so now I want the area of this triangle, and lo and behold, we know the area rule, don't we? So the area rule is a half AB sine C, and so we need to know an angle and the 2 sides surrounding it, and luckily we have that. Okay, so that means that the area is going to be a half multiplied by 19.2 multiplied by 14.4 multiplied by sine 58.7. Okay, so we've got there 118 centimeters squared. Hold on, things. So this one's directly beneath D. So A to this one, it goes through the center of the what's it? Yes. So that's the hypotenuse of that base. Yes, are we good with that? Oh, we don't know that either, do we? Oh. Let's call it something then. Right, we've got Simon, Trevor, and
Oh, we do know. Take
17. Alright, so this is J. This is 17. Alright, shush. So we're finding next AD. Do we know D to Dukai? We do, don't we?
That's a better one. I like to go on.
Oh, what was I supposed to say? Chekai. So we've got 8 squared plus 17 squared and square rooted. Right, apologies, I listened to my, I'd say able assistant, but not so able here. So A to J is the same as B to C that we found out. It's not the same as A to B tonight. B to C. So B to C was what, 19.2. So this is 19.2. So this is 19.2. What a big mess. Okay. Okay, so that's 20.8. Just the ends. The end. Stop.